Was the universe fine-tuned for life? The fundamental question of whether our universe was specifically designed to support life is a subject of great debate and curiosity. From the ancient Greeks to modern-day scientists, humans have wondered about the conditions necessary for life to exist in the vast cosmos. Today, modern physics and astronomy have given us new insights into this age-old question. One of the most profound discoveries in recent cosmology has been the existence of dark energy, a mysterious force that causes the universe to expand at an accelerating rate. Despite its profound role in shaping the cosmos, dark energy remains poorly understood. What's even more puzzling is that, according to the laws of physics, dark energy should be much stronger than it actually is. In fact, if dark energy were even slightly stronger, life as we know it could never have emerged. This leads us to wonder, is our universe fine-tuned for life? Or is it simply an extraordinarily lucky coincidence that conditions are just right for stars, planets, and life forms to exist? Let's delve deeper into this question and explore why the very existence of life in this universe may be an incredibly unlikely event. The role of general relativity, gravity and spacetime. To understand the effects of dark energy on the universe, we must first consider general relativity, Albert Einstein's groundbreaking theory of gravity. Unlike Newton's law of gravity, which treats gravity as a force acting between two masses, general relativity proposes that gravity is not a force at all, but rather a curvature of spacetime caused by mass and energy. Imagine spacetime as a stretching fabric. When a massive object, like a planet or star, is placed on this fabric, it causes a dip or distortion. Smaller objects, like moons or satellites, then move along the curves of this fabric, which we perceive as gravitational attraction. General relativity also provides the framework for understanding the accelerating expansion of the universe. On large scales, instead of objects being pulled together by gravity, they are being pushed apart. This expansion is driven by dark energy, which appears to have a negative pressure, pushing the universe to expand faster as time goes on. This counteracts the usual gravitational attraction between matter and leads to what we observe as accelerating cosmic expansion. Energy density and pressure, the cosmic balance. In Einstein's theory, mass and energy both influence the geometry of spacetime. Energy density is a measure of how much energy is packed into a given volume of space. On the other hand, pressure describes how much force the matter in space is exerting on the surrounding universe. When the energy density is positive, the space around that energy is typically compressed due to the gravitational pull of matter. However, if the pressure is negative, as it is with dark energy, it causes the space itself to expand, a phenomenon we see manifesting as the accelerated expansion of the universe. This negative pressure is not something we encounter in everyday life, making it difficult to visualize. However, we can think of it in terms of forces like magnetism, where unlike poles attract, and like poles repel. If dark energy is indeed a type of field with negative pressure, it acts like an invisible cosmic force that gently pushes everything apart, accelerating the universe's expansion over time. The surprising smallness of dark energy. One of the most baffling aspects of dark energy is just how small its energy density actually is. Dark energy makes up about 68% of the universe's energy content, yet its density is incredibly low. In scientific terms, the energy density of dark energy is about 10 to the power of 9 joules per cubic meter. While this may seem like an insignificant number, it has a profound impact when applied over the vast scales of the universe. Despite the fact that dark energy makes up most of the universe's total energy, its value is much smaller than theoretical predictions from quantum field theory would suggest. Early models predicted that dark energy's energy density should be in the order of 10 to the power of 45 joules per cubic meter, which is so large that it would result in a completely different universe, one devoid of structure and life. If the predicted energy density were correct, the universe would be a chaotic void, expanding so rapidly that stars and galaxies would never have had the chance to form. What would have happened if dark energy were stronger? Imagine a scenario where dark energy's density was much higher than observed. If it had been significantly stronger, it would have dominated over gravity much sooner in the universe's history, preventing the formation of galaxies, stars, and even atoms. In fact, if dark energy had been slightly stronger than its observed value, the gravitational attraction between particles would have been too weak to allow atoms and other structures to coalesce. Without the formation of matter, stars would have never ignited, and the elements necessary for life would not have been able to form. If dark energy had been even stronger, the expansion of the universe would have happened so quickly that matter would have been scattered too far apart to clump together at all. This would have prevented the formation of galaxies and cosmic structures, leaving the universe essentially void of anything other than dark energy itself. Life, as we know it, would be impossible in such a universe. What if dark energy were weaker? On the other hand, if dark energy had been weaker, the expansion of the universe would have slowed more rapidly over time. Gravity would have eventually taken over, causing all matter in the universe to collapse back in on itself in what's known as a big crunch. This scenario would have resulted in the rapid destruction of galaxies, stars, and planets long before life had the chance to form. This delicate balance between expansion and contraction is critical to the formation of the universe's structures. If dark energy had been even slightly stronger or weaker, it would have fundamentally altered the course of cosmic history. There would have been no galaxies, no stars, and no planets. Without such structures, there would be no possibility for life. The fine-tuning of the universe. The fact that the energy density of dark energy is precisely what it needs to be to allow the formation of galaxies and life has led many to wonder if the universe was fine-tuned for life. It's difficult to dismiss the apparent coincidence that the universe's parameters just happen to be perfect for the emergence of life. This raises the question, was this all the result of pure chance, or is there something more at work? Some theories suggest that our universe might be part of a multiverse, a collection of many universes, each with its own set of physical laws. If this is the case, our universe could be one of the few that happens to have the conditions needed for life. In a multiverse, the odds of us existing in such a universe would simply be a matter of chance, with countless other universes unable to support life due to their different properties. Others have proposed that the universe might be the result of cosmic design, implying that some form of higher intelligence or principle set the parameters of the universe with life in mind. While this idea is speculative and philosophical, it raises important questions about the nature of existence and our place in the cosmos. Quantum field theory, the strangeness of dark energy. Quantum field theory, QFT, is one of the most successful frameworks in modern physics, explaining everything from the behavior of particles to the fundamental forces of nature. According to QFT, the energy density of dark energy should be far greater than what is observed. Scientists have speculated that there might be some unknown forces or particles, yet to be discovered, that help bring dark energy's value down to the low level we observe. These particles or forces could act like a cosmic balancing mechanism, counteracting the extreme values predicted by the theory. This discrepancy between theory and observation is one of the greatest mysteries in modern science. If QFT is correct, why does dark energy behave in this way? Could there be unknown factors at play that we are only beginning to uncover? The answer to these questions might change our entire understanding of the universe. The unlikely coincidence. Life against all odds. The fine-tuning of the universe is a deeply fascinating and perplexing topic. It seems incredibly improbable that the conditions for life would arise from a random set of circumstances. In fact, if dark energy had been even a tiny bit stronger or weaker, we wouldn't be here to ask these questions. The fact that we live in a universe where atoms, stars, and galaxies can form, and that life can emerge in the midst of all this complexity, is one of the most profound surprises in science. So, was our existence a cosmic accident? Or is there something more